Welcome back to IM1, everybody. Today's topic 5.2.1. How can I describe a sequence? The learning target for today is by the end of this lesson, I will be able to identify arithmetic and geometric sequences. So, again, you guys have been exploring pretty much exponential functions, and now we're going to be talking about how those, if you guys remember, those change by multiplying, right? The linear functions change by adding. So, again, we're going to be talking about now sequences, which pretty much relates to both of those. So, Samantha was thinking about George and Lenny and their rabbits. When she listed the number of rabbits George and Lenny could have at the end of each month, she ended up with the order list below called the sequence. So she had 6, 18, 54, 162. She realized that she could represent the situation using a sequence generating machine that would generate the number of rabbits each month by doing something to the previous month's number of rabbits. She tested her generator by putting in a first term of 6, and she recorded each output before putting it into the next machine. Below is a diagram she used to explain her idea to her teammates. So she inputs a 6, right? Something happens in the sequence generator machine, right? It relates back to the function machine that we saw last semester. So an 18 comes out, and then again, the new number, 18, goes back into the sequence generator. Then the new number, 54, comes out. That one goes again into the sequence generator, and then pretty much the next one that comes out is 162, and so forth. And let's see what happens, right? So what does Samantha's sequence generator seem to be doing to each input? So if you guys notice here, pretty much we're not, right? If we were to think about adding 6 plus 12 gives us 18, but if I add 12 to 18, I get 30, not 54. So here, what's actually happening, right? It's the new number, each input is being multiplied by 3. What are the next two terms in Samantha's sequence? So one of the things we can do here is pretty much just multiply to figure out, right? So we have a new machine here. This one's going to accept 162. And then, so we know it 162 times 3. We pretty much figure that out, and that's going to give us 486. So that would be one of the next terms, right? So 6, 18, 54, 162. So we know 486. And again, this one comes out, it goes into the next one. So 482. So this would go into the new machine, the same machine, doing the same sequence. So 482 times 3. And that will give us pretty much 1458, right? So 482 times 3. So 1458. Samantha decided to use the same sequence generator, but this time she started with a first term of 4. What are the next 4 terms in the new sequence? So remember. So again, if we start off, whatever number comes into the machine, right, it's being multiplied by 3. So this time we started off with 4, multiplied by 3, we get 12. So we start off with 4. The next term is 12, right? So that would be the second, third, fourth, and fifth term, right? So we need those as well. So 3 times 12 gives us 36. That would be the next term. 3 times 36 gives us 108. 3 times 108 gives us 324. So pretty much that would be the first numbers in the sequence. All right. So problem 542, sequence families. Samantha and her teacher have busy creating new sequence generators by the same they produce and the sequences they produce. To the right, the sequence and her teacher created. Your task is to pretty much organize into sequence a family of similar sequences and then decide which ones have a common feature. So you want to split them up into the ones that have either an addition, right? They're changing by either adding or subtracting. And then the other one should be either by multiplying or dividing, right? Or dividing. So let's see how this one changes. A is changing by, so if you guys notice, we went from -4, -3, +2, +5. So here we're adding 3. On the next sequence, we have 0, and then 1, and then 4, and then 9. So for C, we're actually squaring the number, right? So we're squaring each term. So 0 squared, 1 squared, 2 squared, 3 squared gives us those terms. For B, let's see, we have 1.5, 3, 6, 12. In this one, we're multiplying by 2, right? We're doubling up each time. For D here, we have 2, 3.5, 5, 6.5. So this one's changing by adding 1.5. And then for term E, you have 1, 1, 2, 3, 5, 8. So to generate this sequence, you actually have to add the two consecutive terms to get the next term. So here you add 2, and then 1 plus 2 gives you 3. 2 plus 3 gives you 5. 5 plus 8 gives you 13, right? I'm sorry, this is 8. And then I missed this one, 5. 13, and then 8 plus 13, you get 21. So for this one, you have 9, 7, 5, and 3. So here we're not adding or multiplying or dividing. We're actually subtracting by 2. In this one, you have 48, 24. So this one's getting smaller, right? So when you guys notice things are getting smaller, you're either subtracting or dividing. In this case, we're dividing by 2. And then here we have 27, 9, 3, and 1. So here it seems like each new term is being divided by 3. For the next one, we have 8, 2, 0, 2, 8, 18. This one's a little bit different, right? Because if you guys notice, we start off like that. Okay, so here we subtracted 6, and then we subtracted 2, we added 2, and then we added 6, and then we're going to add, seems to be like 10. So 2, 6, 10, and so forth. So this is neither, I would say. And then for this one, we keep multiplying everything by 2. So here we multiply everything by 2. So again, these right here would be the sequences that you would classify as adding or subtracting, right? These right here. This one. And then the other ones, the other sequences we have, let's put them in green. The ones that change by multiplying or dividing would be that one. Would be this one, right? Multiplying the number by itself. This one, and that one. And then these two would fall into their own category, right? Which would be pretty much C and I. I'm sorry, E and I.